Hi, my name is Jason Harlow. Welcome to my V Office Hour. I'd like to go over Physics 131H1S Winter 2011. This is term test 1 and question 3 from version 1. This question is based on Night chapter 4, Kinematics in 2 dimensions, and in particular acceleration, the 4.1 section on finding the acceleration vector based on a motion diagram. Okay, so let's carefully read the question. The motion diagram shown in the figure represents a pendulum released from rest at an angle of 45 degrees from the vertical. The dots in the motion diagram represent the positions of the pendulum bob at 11 moments, separated by equal time intervals. Also given is a compass rose in which directions are labeled with the letters of the alphabet. What is the direction of the acceleration of the object at moments 0 and 10?
Basic idea with this one is just that the acceleration is the difference between a velocity vector and the velocity right before it. So from point 0 to point 1, all that happens is that the velocity increases a little bit down and to the right. So your acceleration, if you're released from rest there, is down and to the right. If you look at the vector between 1 and 2 and the vector between 0 and 1, it's a little longer and a little towards the right, but it hasn't changed its direction much. So for point 0, the correct direction is D. Up for point 10, it's going up and to the right, and all that happened didn't change its direction much, but did shrink its magnitude a little bit. So it's slowing down, so the acceleration is opposite the velocity. And again, so for point 10, it looks like the best choice there for direction would be F. So it's D at moment 0 and F at moment 10. So my selection there, it's A.
To assess this, I will just jump ahead a little bit. This is a pendulum moving in a circular path. So circular motion, we know, has centripetal acceleration towards the center of the circle, which is proportional to the speed, and it also can have tangential acceleration if it's speeding up or it's slowing down. So it's interesting that just at moments 0 and 10, that's where the pendulum stops. So the speed goes to 0, meaning that any centripetal acceleration component will also go to 0 at those moments. And whereas that's where it is speeding up because it's getting faster, or it's slowing down up here, so there will be a tangential acceleration component. So at those two moments, it's all tangential, which is why the acceleration is in the directions we found. So I think it all holds together and makes sense. My name is Jason Harlow, and I approve of this message.